Have you ever heard of a piecewise function? It's defined by two or more equations. In this case, I have two equations, and each piece of the function applies to a different part of the domain. So here it's saying that my f of x is going to equal x minus 2 if x is less than or equal to 0. So that's 0 and all the negative numbers. So this is what that equation would look like. You would have a point on the -2, and then you would have domain, you would have a slope of this 1 here. But if you're talking about the domain, your x is bigger than 0, like 1, 2, 3, or anything in between, you're going to have this equation, 2x plus 1. So here's my 1 and rising 2 and running 1 right, and there's what that graph would look like. So they're asking me to evaluate when x is 0. What you have to do is figure out which one you want to use. If x equals 0, that would have to be this one because this is x is less than or equal to 0, so I've got to use this one. I will say f of, we're using 0, equals, and I want to use the top one, so it's x minus 2. So that's f of 0 equals 0 minus 2, so that will be -2. So f of 0 equals -2. And then they're asking you, well, what would your answer be if you have x is 4? Well, 4 is a positive number, and this one is the one we use for positive numbers. So I'm going to say f of 4 equals 2 times 4 plus 1. I'm using this formula here. And 2 times 4 is 8. And 8 plus 1 is 9. So f of 4 equals 9. This means we're talking about a 0, -2 in the graph. And here we're talking about 4, 9. Let's see where 0, -2 is. 0, -2 right here. And for f4 of 9, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be right here as it kept going.